Hey guys, this is Scripted Channel, and here we try to make sense of AI. This is part 4 of our survival guide for coders and tech, and today we'll be talking about this creature, the black box. About 10 years ago, it has destroyed data scientists. And now, in 2024, it is wiping out coders and tech, the same black box. So what do we need to know about this creature if we want to survive? To get this sacred knowledge, we don't necessarily have to watch the previous parts. Even if something won't be clear at first, I'm sure we will figure it out eventually. So just jump in. So previously, in part 3, we have seen how 10 years ago data scientists were making big money. They were applying very complex and sophisticated models like stochastic equation, random forests, and so on, to make the machine, the internet, more efficient. And in return, the machine paid them handsomely. But there were a few groups of stubborn and fanatical scientists who refused working on this mainstream data science models, very complex equations. Instead, they kept working on a completely separate branch of data science. They kept working on replicating human brain. But that was an uphill battle for them. Many got defeated, many got surrendered to the mainstream data science. They followed the money, they betrayed, they abandoned their dream of replicating human brain. This team of nerds, they were the last Spartans keeping resistance, fanatically building a replica of a human brain. Led by Geoffrey Hinton, they were holding those defense lines, those trenches in computer science faculty of the University of Toronto. As we have seen, all teams that were trying to build a replica of a human brain, they all faced the same problem. It is because neurons, the layers and layers of neurons, they were all interconnected to each other. And each connection required a constant recalculation. So because of that, because of the billions of neurons, the whole model was taking months and sometimes years of supercomputer time to train it. So that basically was a very, very slow brain. So basically all deep learning models and all neural networks, they're effectively matrices, like layers and layers of matrices interconnected to each other. And calculating those connections is an extremely tiresome and expensive process that takes like ages and millions of dollars. So it all makes it prohibitively expensive and difficult to run these models. But guess what? Aren't they the only matrices that are around us? Look around. Do you see any other matrices? So I bet you do. Look at me. Because, well, I am a matrix. Fun. It sounds really fun, but actually indeed, I am a matrix. You see that screen? So that screen is effectively a matrix of pixels. And there is a special type of processors, GPUs, that actually are designed to calculate those matrices for gamers. So that team in Toronto, they tried to run their deep learning neural network on GPUs, on these graphic processing units. And guess what? It turned out that what works for matrices of pixels actually works for matrices of neurons as well. They called their model AlexNet, and they have submitted it to an international image recognition competition. Well, image recognition back then was one of those tasks where all data scientists were competing at. So very quickly, it turned out that this model, this AlexNet, the deep learning neural network model, it became much more efficient than anybody else, any other model, any other manually operated claw. So it became much better at recognizing cats. Yeah, hello. We haven't forgot about you. Well, of course, it wasn't just about cats. It's just because cats since then became so emblematic, so like iconic, so everybody kind of using them.
This, as you know, was First Contact, 2012, AlexNet. You put a cat into this computer, and it comes out and it says, cat. And we said, oh my God, this is going to change everything.
So, cats. So it turned out that this AlexNet became more efficient at image recognition than anybody else. Retrospectively, that moment will be known as the first contact. It's basically the first time a functioning replica of a human brain was built. But back then, in 2012, not many people understood what had just happened. Most people, like myself, they just kept operating that manual claw. But a few guys, a few visionaries, the second they heard that meow, that second they knew what had happened. They knew what that meow meant. And this guy, he was one of them. His name is Andrew Ng. And he's a co-founder and one of the co-founders of a small and insignificant company called Google Brain. And what did he do when he saw the first contact? Well, he bought it. A few weeks after the first contact, Google has acquired AlexNet. And that's where the things took a really crazy turn. YouTube is one of the most powerful systems and overall things in our world. It basically controls what we know, it controls what information we receive, it controls what we think. It basically forms our opinion, well, at least in the Western civilization. If there is one thing, one element that makes YouTube so powerful, that's definitely its recommendation system, its algorithm. So it's like a claw, the claw that we all know that well now. So that claw is looking through the flow of millions and millions of new videos that are being uploaded onto YouTube daily. And that claw knows your preferences. It knows what were your choices in the past. And it is trying to pick the videos that you will like. So it's a personalized approach. It is trying to pick a video for you personally, the videos that you will like. Talking about likes, if it so happens that you are a happy owner of an extra like that you don't need, look at this guy. He definitely looks like he needs a like. YouTube had this algorithm, this claw, since the beginning. And it was managed by human data scientists, a team of probably some of the most advanced and sophisticated data scientists you could find back then. All of them with PhDs sitting on tons and tons, years and years of research behind each one of them. And they spent a decade playing with the models, playing with feature engineering, with the objective of, with the goal of maximizing average viewership time. So they spent a decade and they have achieved quite impressive results. So after a decade of work, they have managed to get 20 minutes of average viewership time. So very impressive, 20 minutes. And then this happened. Do you remember our old friends with a cat and the brain replica? Yeah, the deep learning dreamers. So after the first contact, Google Brain acquired them, that we saw. But guess who else is owned by Google? That's right, YouTube. And this is how our friends ended up being parachuted into YouTube. And one of the things that they were trying to do, they were trying to apply the brain replica to recommendation system, to the claw. And guess what? The first day, literally overnight after they replaced the human data scientist, the first day, the brain replica, the deep learning model, has increased the average viewership time from 20 minutes to 40. It doubled it. YouTube videos began to stick, meaning when we watch one video, then we want to watch another one, and then another one, and that another one, and that never ends. So somehow that YouTube algorithm, that brain replica learned what we want, and it gives us to us. Revenue of YouTube went through the roof, but that's not what is important. What is important is that this was the first time that we saw this creature coming, the black box. Here, I want you to pause for a second and think what that YouTube moment actually was, that coming from 20 to 40 minutes. Because on the one hand, that was the birth of the most powerful mechanism on this planet. Just think about it. YouTube currently is watched by more people than anything else. And this is not just on the US. This is on the entire planet. Well, except China. YouTube is a mechanism that decides what people think. Because it's a YouTube claw that picks a video. It's a YouTube claw, that algorithm that decides what information people will watch. Just think about it. And again, this is on the entire planet, except China. And on the other hand, that moment was the first time in history when a replica of a human brain was turned on, not just for some scientific project or a competition, but for a real-life, large-scale application. It was the first time when the artificial brain was turned on. And it is never gonna be turned off again. Never. So we got distracted here a little bit. But there is actually one point that we need to make here, or rather ask one question. And as we will see soon, this is a cornerstone question to our survival. So, how exactly that algorithm works? It's not a trivial question, because how did it happen that overnight, literally, just in one day, that human brain replica came in and it doubled the result of the system that some of the best human data scientists in the world have spent like decades working on? How could that happen? Well, the answer is that we don't know. The thing is the way how this brain replica works. It's basically like a big black box for us. So the inputs are coming in, then inside something happening, and then the outputs are coming out. And we don't really know what is happening inside. But the thing is that we know that the whole thing actually works. So the outputs, they make sense, and they are better than what human data scientists could produce. Don't get me wrong, it's not like we're completely clueless about the black box and how it works. No, that's not the case. We do understand the structure of the black box and the mathematics behind this, so we understand how all these neurons are connected. What we do not understand, though, is the logic of each individual decision that black box makes. For example, this video, the videos that you're currently watching, YouTube recommended it to you. But if we try to understand why, if we try to roll back and see the logic behind this, we won't be able to do that. So that part we do not understand, the logic behind each individual decision that black box makes. To some extent, this type of decisions, we can compare them with intuition. Because sometimes we make decisions based on intuition, and then later we cannot really explain them even to ourselves. But the way how it works is that very often our brain detects some tiny, small, minor clues can be just like a smell in the air, a tone of a pheromone in the air. It could be a facial expression. It could be like a million different things that we cannot detect, but our subconsciousness learned to detect, and it learned to process it through the layers and layers of our neurons and past experience to come up with that intuitive decision. A decision that makes sense, but we cannot explain it. So that's intuition. And it's basically like a black box for us. Since besides being an AI guy, I am also a behavioral economist, I'm going to use an example from behavioral economics to illustrate these concepts. It is an extremely primitive one, but it's a real one and it does work. So, this video, there is a good chance that if it's the first time you are on our channel, it's a good chance that you clicked on it because you have seen that it has many views. Well, hopefully it already got lots of views. The thing is that we often don't want to be first. We don't want to experiment, and we don't want to click on a video and then find out that it was another clickbait or it was just another boring video or something like that. So when we see that the video has already accumulated some substantial number of views, that probably means that there is nothing like hugely wrong about this video, so it's kind of safe to click, and this is why we click it. So we rely on the opinion of others. This mental calculation often happens automatically without us even realizing it. It's like a shortcut. It works, and this is why we learn it since childhood, but very often we are unable to explain it, so it really goes automatically. It is triggered automatically. So the concept itself is simple, right? Yet very often we are not able to explain it, especially when we are in a rush, so it just happens automatically. And that's basically what makes it like a black box for us. And the same thing happens on artificial brain replicas in the neural networks. So it appears like a black box. There's connections, that's a shortcut that is made inside of the black box. So it is there, but we cannot explain it. Black box. Remember those tens of thousands of data scientists who were building new models? Basically, it's almost overnight. It turned out that all these models, highly sophisticated stochastic equations, random forests, and hundreds of other types of models, overnight it turned out that they are all unnecessary, they are all obsolete, and just all these hundreds of thousands of PhD works suddenly turned out to be completely useless and just rotting on the dusty archive shelves. Feature engineering, those tens and tens of thousands of data scientists for whom that was, they were making their living on this feature engineering. Overnight, they have become completely irrelevant. It turned out that this new model, that black box, was capable of doing feature engineering automatically. You don't need a human for feature engineering anymore. And the same thing happened with data cleaning. And data cleaning was bread and butter for all the junior data scientists. So this is what they were doing. And it turned out overnight that this new this new model, the neural network model, it was able to digest any sorts of data, no matter how dirty. Just throw it into it, throw it into it.
Wait a minute, what are you doing, Doc?
I need fuel. Go ahead, quick, get in the car.
That's all what was needed. So there is no need for data cleaning anymore. Well, almost no need for data cleaning anymore. Isn't that ironic that the first profession that AI killed was data science, its own creators? I think it is ironic. And this is where many of you probably shaking your heads and like, hey, what this guy is even talking about? Isn't data science the most in-demand profession now in 2024? Well, technically you're right. But there is one little nuance. So if we look at those data science teams in big tech, those teams that are building all these LLMs and black boxes, we will notice that most of them are young. They're like super young. They're like kids. So this is definitely not the same data scientists that were there like 10 years ago in that first contact. That's completely different people. And here's the question. The most important question for us, for coders.
Don't know about this new crew of yours. They seem a bit skittish. Probably shouldn't tell them what happened to the last crew.
Yeah, so what exactly happened to the last crew? In just 10 years since Black Box appeared in 2015, it has annihilated about 50% of data scientists. They all retired. Well, the good news is that they were able to retire because they used all those savings from the old good pre-Black Box time. However, about 40% of data scientists did not have resources, so they could not retire. And they had no other choice but to follow the COBOL path. It's like a dinosaur path. For those of us who don't know what the COBOL is, I encourage you to go and Google it because this is quite a story. But basically COBOL, here's a brief summary. COBOL is a programming language that was invented like in 1958, like 70 years ago. And it is still in use, it's still being used. There are like tens of thousands of COBOL coders who are programming in it. It is mainly used by banks and it is used for transactions. But it is a dinosaur path. So those data scientists who could not retire, they stubbornly kept using those old models that were made obsolete by the black box, and they basically chose that dinosaur path. For those of us who thought for a second that, well, maybe this COBOL path, this dinosaur path, maybe it's not so bad. Well, think again, because do you know how much banks are paying them? I can tell you, it's like a fraction of what it was before the black box. So it is obvious that the dinosaur path is a path into oblivion. So we have 50% retired data scientists, 40% turned into dinosaurs. So what happened to the remaining 10? And that's when it's getting interesting. In the beginning, when clay is still soft, a piece of pottery can change its form. It can adapt to the external forces. But with time, it dries, it hardens, and the only thing it can do after that is to break. Human mind is very much like pottery. Our mind in the beginning is soft and it can adapt, it can change to the external forces and can absorb new information. But with time, it dries. And the only thing it can do after that is just keep doing what it has learned in the beginning, even if it does not make any sense anymore. However, some people, just about 10%, they somehow manage to find a way to keep their mind soft, to keep their clay wet. And they keep being open to new ideas, and they adapt, and they survive. And that's what has happened to those 10% of the data scientists. Once they have realized the importance and significance of the black box, they have reinvented themselves. They have learned the new ways. And instead of resisting the change, they have rode it as if it was like a wave. And they have survived. Some of them turned into AI researchers, others became AI project or product managers. So basically they became AI enablers. And they survived. They survived the first wave of the black box.
I said, empty your mind. Be formless, shapeless, like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash. Be water, my friend.
Everyone has his own way how to keep the clay wet, keep the mind soft. And I'm going to share my approach. It's probably one of the many different approaches possible, but I'm going to share it just because it worked for us. So when we hire new data scientists we try to get as young professionals as possible, like straight from the uni. And the reason for this is because their mind is soft, and their mind is open to new ideas, and they bring those ideas with them. So when you add a young, soft mind into a team, the collective mind of the entire team becomes softer as well. And this is how we resisted the temptation of keeping the status quo. And this is how we abandoned ideas that no longer worked. So that's how we adapted to the black box. We enter a new era, the era of rapid change. Knowledge and expertise, they don't matter as much as they used to be in the past. Knowledge depreciates, especially technical knowledge. It rottens like a fish on a tropical sun. So knowledge doesn't matter that much anymore. What matters is recent knowledge. So recency matters. To sum it up, this is what we have learned from the data scientists. Be around young professionals. Surround yourself with them. Learn from them. Just watch what they do. So that's our survival rule number 1. Be around young professionals. And right away, our survival rule number 2. So we have seen that technical skills, they don't matter that much anymore because a black box makes them obsolete faster than you can acquire them. But soft skills still matter. So here's rule number 2. Train your soft skills. Train your people skills. I can hear the coders like saying, all right, okay, we got it. The black box came in 10 years ago and it killed like 90% of data scientists. But why does it matter for us, for coders and tech people now in 2024? Why do we have to pay attention?
Attention. Attention.
Can you hear it?
Attention.
Damn it, it's already here. All right, guys, I think we got to the end of part 4. And if we want to get to make part 5 sooner, first go and find that click button, that like button, and click it. Then there is another thing, like if you're really hungry for part 5, just leave a comment and make it like just something like, hey, we need part 5. Or you know, even better is like, where's our part 5? Like something like that, like caps locks, right? Yeah, so it definitely motivates us. It definitely makes the things faster from on our side. All right, so, one more thing. The videos that I promised you, so here's a link. It's first contact. It's about first contact. It's actually quite a story. When I figured out, I was shocked. And since then, I never really looked at the history of AI evolution the same way. Well, as a matter of fact, not even at the entire human technological progress. So it definitely makes you look at the whole process from another perspective. So highly recommend just watch it. I think it's, at least I enjoyed making that video a lot. All right, I think that's it. See you on the other side.